Okay, let's start with these facts. Matrices and vectors are important. Learning to use CAD and paper are both important. Putting them together is incredibly important, and it blends your skills together. So I'm going to go through a couple of things right now to show you why, in fact, you don't necessarily jump to simplification by adding vectors, but then again, why it's just a beautiful thing for solving reactions. You might want to look at this if you're struggling in the first minutes of this exam today, this retest for just reactions. And so I put in front of you something that's got a sketch and call the red lines the structure. It's a framed up structure, and we're going to do this for this and a truss. And I see now all of a sudden it's red, and I got some dimensions there and I can't read them. So what do I remember? I remember dim style. And with dim style, hopefully when I go to here, I can modify only one place, and that is the fit tab. But then again, there's more to it than that, because then every now and then you might want to change the primary unit so you don't carry around 4 places that you don't need. I hit OK, and I hit close here. Now I see that's 20 feet. The rest we're going to do by, if we remember, we've got a start x, a start y, a delta x, and a delta y. And we change our coordinates system by saying UCS, telling it at the endpoint there, and then entering to accept, so that when I go to here, that circle perhaps, it shows me it's not a circle. That line is going to show me the delta x and the delta y, and it goes 20. Now that line, of course, is the spine. I'm going to just draw 3 forces on here. I'm going to draw them in a way that many of us forget sometimes we can do. I can just move my mouse in the right direction, and I'm going to say 4 for 400 now. I'm going to take a line here. I'm going to go from the end point there. I'm going to go this way. I'm going to say 3 for 300. And I'm going to go a line from the end point here in this direction. And I'm going to say 2 for 200. Now, what I didn't do, if you remember, I didn't put a little thing on the end, so I'm going to draw a little circle. That's what that Lisp routine was. Draw a little circle out there, so I know that's the front of that circle at the end point of this. I know it's supposed to be an arrowhead, but we're just going to do a circle today. We'll look at that Lisp routine. All right. First and foremost, remember that, oh, well, everything's green. That's not a good idea. So getting in your head that maybe dimensions, right, things want to be on the right layer, so you might want to take that dimension there, change its right-click properties if you do it that way. However you're going to do this on a regular basis early and often. I'm going to go ahead and change that, of course, to the dimension layer, and you're not going to necessarily need to do that a lot. And then I'm going to realize, that's red is red, that's not good, so I can go to layer and go to dimension here and change the color of the dimension layer, especially if you are colorblind, and close this out. Now let's remember that in fact this is all it's going to be. If I've changed my user coordinate system, all I've got to do is write down in a matrix 7 next to 2.5 over 0.15196 and minus 1.9313, cross across the right way, the right diagonal plus, subtract the left diagonal, go to here, go across, look at those 10, 5, 3, and minus 2.4, stack them xy, xy, right diagonal minus left diagonal, do the same thing here, right diagonal minus left diagonal, and then divide by, in essence, we're going to put a reaction forces here. Right now we're going to go ahead and put reaction forces in, showing us where the lines of force are. So I'm going to go layer, new, force underscore reactions, and I might want to put that in a different color. I guess I've got it. That one will work for me, and I have to remember that right now the line from there, remember I put it up with in the up direction with a distance of 1. That of course would then in the end be 100 when we're done, won't it? Because our forces are now at a scale of 100. 1, and then line from the end point here in this direction with 1. Now of course we remember UCS icon. it gets in our way sometimes. We need to put things on the correct layer. So I'm going to take that one, that one. These things help visually. That's what your colored pencils are for. So right there, the force reaction. Realistically, right now, if we're going to use the way of just pulling data off this way, right, this way, and this way, and this way, we might even want to get rid of those dimensions. So you get used to doing right-click in any tool, bring up a set of toolbars, your layers tool. Hopefully you would go ahead and find the freeze and get rid of the dimension layer. Now, however, let's remember what we can do. We can do this. Minus layer, new, line of force. We can do layer, change my line of force. That's why you set with something hopefully that makes some sense. Line of force here, double click. Great use of the X line. X line from the end point of here to the end point of there. Another great use, I think some of you know how to use the line to the apparent intersection. Line here to the end of there. Undo. X line from the end point there to the end point there. This should be a preferred first solution for many of you, but only for solving for reactions. Remember, left click, right click, draw order, send to back. Use the tools you have. And now let's go ahead and, in this case, I'm just going to go ahead and move them around. Though in all reality, you would want to maybe just do some copies. Left click, spacebar, move, shift click to the intersection of that. And I'm going to take left click here, left click, spacebar, move to the right click endpoint of that. And the reason why we go about doing that and the moving is because we're not going to solve for the forces inside. Otherwise, you really don't want to be doing the moving because the forces are not here, they're here and here. That said, now we go ahead and match properties to there, and then we go ahead and do a line from the endpoint there to the endpoint there. We don't have these anymore. They don't exist in all reality. Those two lines of force don't exist either. And so now what do? You do a line, you go back to your line of force. Much easier done, of course, on paper. X line from the end of this to the end of this. Now you've only got to move one, well, you got to move two basically, don't you? So we're going to go ahead and left click this, left click, spacebar, move to the intersection of there. And we're going to go ahead, remember, draw order. We can't see that underneath, so right click, draw order, send to back. I'm going to left click, spacebar, move, shift, right click, endpoint there. And now, of course, line from the endpoint there to the endpoint there. That line should be, in fact, on a minus layer, new, force, underscore, resultant. Layer. And we're going to keep our resultant in green, though very often you might want to have the green, that in something else. I'll go ahead and put it in green. If in fact you're keeping your other forces around, you wouldn't want it in green, but in fact those are not there. And this, of course, is in what layer? It's in force resultant. That, in the end, is now a way that you can, once again, do this product. And so I'm going to do that now. This, of course, if I hold my mouse over that, I have, in an essence, a start X, a start Y, and a delta X. Remember, those delta X's in this case are in fact hundreds. So my X is 799.19. My Y is 5.4563. My X is 7.9919. My force in the X is 78.42. My force in the Y is minus 511.71. I'm going to pause here and stack that up and then realize that this resultant has to be reacted to by this resultant, and this is 20 away. So I'm going to hit pause here and bring up a little bit of a PowerPoint. Just realize that later on you have to put everything back. So that's one reason why not to simplify. But in this case, we're just solving for reactions, and that is the sum of the other three forces. and hit pause. All right, remember we're going to go this way minus this way. So our numbers were 7.99 times a minus 511.71 equals. So that's, and my minus, you realize I blew my minus there, and then you're going to go ahead and minus again. 5.45 times 78.42, and then divide by 20. That's your solution. Thanks for listening.